Greetings everyone. Welcome back to the course Mechanics of Road Vehicles. We are discussing about CO number 4, analyze the tractive characteristics of vehicle for different types of drive. We are in unit number 4, vehicle performance. The topic of resistance and tractive forces. Our specific outcomes, what we are going to learn here are determine the power required to propel the vehicle. How much amount of power is actually required to propel the vehicle in desired direction. We have to calculate the amount of power and amount of torque and also the force required to propel the vehicle. Second outcome is analyze the various resistive force act on the vehicle. We know that there are lot or many number of forces that may oppose our movement. In vehicle movement also there are some sort of forces will affect the movement. Here we have to learn the number of forces and the nature of the forces that actually opposes the movement of vehicle. That is we called resistive forces on vehicle. We should know the two important terms that we are using in vehicle performance is tractive effort and traction. What is tractive effort? It is a force available between or generated between contact surfaces of tire and road surface. We know that without force, no component will move. We can't change the position of components or objects without any force. If we want to move our vehicle, we need some sort of forces. Tractive force is a force used to move our vehicle. It is generated between contact surfaces of tire and road. We can mark tractive force as Ft, force because of tractive. Tractive force is a longitudinal force because it has to move the vehicle in longitudinal direction. So tractive force will act in longitudinal direction. So we can say it is x direction force. Next one is traction. Traction is the ability of vehicle to utilize the tractive force without slipping. Without slipping is very important. It is the ability of vehicle or ability of wheel utilize the generated tractive force without slipping. In other words, we can say ability of vehicle or ability of drive wheel to transmit this effort without slipping. Both are same. So here we can say traction is utilization of tractive force without slipping. Tractive effort or tractive force calculation. The force available at the contact surface or contact between the tire and road is known as tractive effort or tractive force. The ability of drive wheels to transmit this effort without slipping is known as traction. You know that very well. Here, usable tractive effort never exceeds traction. The tractive effort relate to the engine power as P equal to 25 Nt by 60. So that power available at engine PE equal to we can say 25 rotational speed of engine NE and torque at engine TE divided by 60. Here we can say if you want to calculate the power in kilowatt, it is generated in watt. If you want to calculate in kilowatt, we can say PE equal to 25 NETE by 60 into 1000, which gives the value in kilowatt. The torque available at wheel, we can say TW. Torque at wheel must be equal to engine torque into gear ratio at gearbox into gear ratio of differential into transmission efficiency NT. So the wheel torque must be equal to engine torque multiplies with gear ratio and transmission efficiency. We know that torque is equal to force into distance. The distance at tire, we can say radius of tire, the force act at. So the torque TW we can mark it as F into R, which is equal to TE into gear ratio GR AR. I just take GR as gearbox ratio, AR is axle ratio, that is differential gear ratio, into transmission efficiency eta T. Here the force required to propel the vehicle is tractive force, so I take F as Ft. So Ft is equal to engine torque multiplies with gear ratio. Generally I take G, this GR into AR, I take it as overall gear ratio G, into eta T whole divided by radius of wheel R. So the tractive force is equal to engine torque multiplies with gear ratio and transmission efficiency divided by wheel radius. Here TW indicates torque at wheel, TE indicates torque at engine, Ft indicates tractive force or tractive effort you may call, G indicates overall gear ratio, which is equal to multiplication of gearbox ratio and axial ratio. Eta T indicates transmission efficiency because there will be some sort of loss in torque during the transmission. It may be up to 90%, and R indicates wheel radius. Here we got two equations, one is tractive force, another one is torque available at wheel equal to TU overall gear ratio G into eta T. Thanks for kind listening.